thank you very much. We'd like to start with some historical notes. I want to quickly go through our evolution of our view of the universe. Our understanding of the universe has evolved a lot in the last 100 years. From a very simple picture. Well, I'm very happy to be at this nanospace conference where we are discussing the various aspects of different forms of carbon in the universe. As you see, going back to Aristotle, scientists have a very different view of the universe, always regarded as simple. They think the universe, the celestial objects beyond the moon are much purer and stable than the Earth, which is dirty and complex and changeable. But over the last 100 years, we have been gathering more and more evidence that the universe is actually much complicated than we used to think. So in the 1970s, we discovered there are many different kinds of molecules, including organic molecules, and today we have discovered through millimeter wave spectroscopy over 300 different kinds of molecules. We also found from infrared spectroscopy minerals. There are minerals like amorphous silicates. They were made by old stars. And most interestingly, there's a whole family of unidentified infrared emission features, which are called UIE bands, unidentified infrared emission bands, which origin we still don't understand. And in my talk, I try to propose the idea that these are due to very complicated organic compounds made of mixed aromatic aliphatic organic nanoparticles. And the universe, these kind of organics actually were present very early in the universe, as early as 1.5 billion years after the Big Bang. So whatever it was happening, organic synthesis already was being created in the early universe. Now we have to remember, we have a lot of organics on Earth, but these are all due to the result of living things. So for example, the largest reservoir of organics on Earth is something called kerogen, which is found in sedimentary rocks. But these are the remnants of past living plants and animals. But the organics that I'm talking about in the universe, they were nothing to do with life. They are actually synthesized from simple stuff, simple molecules, and being built up to larger molecules and complex organics. And most interestingly, they all happen over a very short period of time, thousands of years, in the objects called planetary nebulae, which is the last stage of evolution of a star like our sun. So in every star's life, just before they die, they manage to create a large amount of organics and eject them into the interstellar medium. And some of these organics may have been embedded in our primordial solar system and may have been distributed in, say, planetary satellites, in asteroids, in comets, and even possible that some of it may have been in our primordial Earth. So these things which are very important and very surprising that we have such complicated organics in the universe. And in this conference, I'm very happy to hear that we have a gathering of scientists from different backgrounds. Some are doing laboratory work, some are doing theoretical calculations, some are chemists, some are astronomers, and we are hoping to get new ideas on how such complex organics could come into being and exactly what kind of chemical composition these organics have.